So in the last section, we talked about completing the square as a means to solve a quadratic equation. In this section, you've probably seen the quadratic formula before, maybe in some context. Most people have, but we're going to see that the quadratic formula, it's an alternative way to solve a quadratic equation. So it's a way you could do it if you wanted to instead of completing the square. But what we'll see first is that the quadratic formula, it's only made possible by completing the square. So what someone did is what they did was they said, oh my gosh, completing the square is such a pain, which is probably something you said to yourself, maybe even using more interesting, colorful language than that. But I think they said, you know what, and it's more like, it's like a recipe, it doesn't really matter what you're dealing with, you always do the same steps every time. It's not like, oh, if it looks like this, we do this. If it looks like that, we do that. No, it's always the same steps every time. So some really smart person who thankfully, they said, you know what if I just look at a kind of a really general quadratic equation like this guy? Leave A general, ax squared, A could be whatever, plus bx, so B could be whatever, plus C equals 0. This kind of covers all the problems we saw in the previous section. A could be anything, B could be anything, C could be anything. And he or she, whoever they were, they completed the square on this. They followed the steps until they got a formula. So that's what we'll do now. I guess, so if you don't really care and you're not interested in math at all, then you can skip ahead to where we actually tackle these examples. But I was always curious, where did the quadratic formula come from? And then I think I was in pre-calculus when my instructor showed us, and it blew my mind, and I thought, that's the awesomest thing I ever saw in my life. I know, what a nerd, right? But whatever. So I'm going to complete the square on this thing. If you look back at your notes from the previous section, the first thing you want to do with completing the square is move the constant term over, or the term that doesn't have a variable. So remember, in this we're thinking of A, B, and C as just some numbers. So C is actually a constant, it's some number. Now move it over by subtracting. That was step 1. And then step 2 said, if the coefficient of x squared is not a 1, divide everybody by it. Well, we don't really know what A is. It might not be a 1, so we better divide everybody by it here. So far, so good. That'll make the first term become an x squared because the a's cancel. The second term, though, since we don't know what b or a is, we're going to have to just write it as b over ax. And kind of similar for the last guy, I don't know what c or a is, so I better just write it as negative c over a. Alright, that was steps 1 and 2. The third step of completing the square is, now you want to find that magic number. Remember that guy? I'm going to kind of move this off over here. Magic number. Okay, that's going to be, remember, half the coefficient of x, which is b over a. Once you find half of it, then you're going to square it. So that's what I want to do. Half, and of course b over a is a fraction, and even not, fractions are bad enough, but I don't even know what b and a are. So to find half of b over a, all I can do really is multiply across. 1 times b is b, 2 times a is 2a, and then I'm squaring that. So b squared, I'll square that guy. 2a squared, though, if I square the 2, I get 4. And if I square a, I get a squared. So that must be the magic number. That seems crazy, but that's what we're going to add to both sides here. Plus b squared over 4a squared on the left. Plus b squared over 4a squared on the right. And I'm leaving everything else the same that was already there. X squared plus b over ax. And then negative c over a on the other side. Whew, so that was the magic number. Then the next step, if you remember, the fourth step was you want to factor the left side, which should be a perfect square. So this will be x plus or minus something squared. And this, thank God we had that shortcut. Remember, the thing that goes in the parentheses with x is going to be half of this thing, half of the coefficient of x. Half of b over a, we actually found it sort of halfway through our magic number calculation. It was this b over 2a. So b over 2a must be half of the coefficient of x, so that'll go in the parentheses. So we've got the factorization of the left side. The right side, though, we want to combine the fractions into 1. But I see they have different denominators. One's a, one's 4a squared. The common denominator is 4a squared, so I'll multiply the left by 4a over 4a. And that way they'll have the same denominator. Let me rewrite them. That would be negative 4ac over 4a squared plus the same fraction, b squared over 4a squared. And since we're running out of room, let me kind of move this up to back to the top of this little box here. All right, I'm just going to kind of copy the left portion. The left is just the perfect square, x plus b over 2a total squared equals, and now we can add the numerators there since the denominators are the same. But you know what I might do? Instead of writing negative 4ac plus b squared, I'm going to write the positive guy first, b squared, and then minus 4ac. Hopefully that makes sense, just because instead of saying negative 4ac plus b squared in the numerator, I'm going to switch them, that's all, to make it look prettier. But they have that common denominator of 4a squared. And if you're somewhat familiar with the quadratic formula, that numerator might sound familiar. That's part of the quadratic formula, b squared minus 4ac. All right, now the next step was we're going to square root both sides to try to solve this guy for x. And I know this looks complicated, but remember a, b, and c are just numbers. They're some numbers. So really the only variable here is this x. So if we're trying to solve this for x, we're trying to just isolate that guy. So I'm square rooting the left side, square rooting the right side. Okay, and don't forget your plus or minus. On the left side, the square root and the square cancel just to leave x plus b over 2a. On the right side, we have plus or minus. And I'm looking at the numerator, and I don't think that has a nice square root. Like if the numerator just had the b squared, then the square root and the square would cancel. But because it's this complicated thing with the subtraction sign, there's no way to simplify that. It's going to have to stay. But the denominator, notice you're taking a square root of 4a squared. Both of those things have a square root. Oops. Shouldn't have put it equals there. That was a plus. Plus over 2a. All right. So the numerator, there's not really hope for simplifying that. But the denominator, you have the square root of 4, that's 2. The square root of a squared is a. Yeah, because you can think of this as two separate roots. There we go. All right, now we almost have x solved for. I just need to move this b over 2a over. Subtract it. Okay. It's almost done. Let me rewrite it a little higher here. So x is by itself now. And you know, instead of writing the fraction that we started with and then the fraction I'm moving, I'm going to write the fraction we're moving first. Negative b over 2a. And then the plus or minus the big fraction we had. B squared minus 4ac over 2a. And then just the finishing touch would be, since these two big fractions have the same denominator, we might as well put them in one big fraction with their numerators combined. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's the quadratic formula. You've probably seen that before. If not, it's okay. It's fine if it's unfamiliar. But these are the solutions to the equation ax squared plus bx plus c equals 0, because that's the equation that we started with before we completed the square. So now anytime we have a quadratic equation we're trying to solve, what we can do is just identify a. Okay, a is the coefficient of x squared. Identify b is the coefficient of x, and then c is the constant at the end. Once we identify them, we'll just plug them in this formula and then simplify as much as we can. And it would be equivalent to actually using the completing the square method. But notice that this formula wouldn't be possible unless we completed the square. So you can't really dismiss completing the square altogether, because this formula, again, it's only made possible by that. You know, I think of it as kind of like computers. Like if you say, you look at one of those old computers from the 80s, it's huge, you know, it's like as big as a whole room, and you say, oh my gosh, those computers sucked. I like the computers I have now. It's like, well, yeah, of course you do, but the computers you have now are only, you know, they're only possible because of those big old ugly computers. So you could say that the ones we have now are better, kind of like the quadratic formula is better than completing the square. But completing the square is like the grandfather or something of this formula. So anyway, let's try part A here. We got 3x squared minus 7x plus 2 equals 0. So that kind of looks like what we want, right? ax squared plus bx plus c equals 0. Just notice that the b will be a negative, that's all, not a big deal. So first thing you want to do is identify what a, b, and c are. A is the coefficient of x squared, which is 3. B is the coefficient of x, which is negative 7. Don't forget the sign. And c is the constant term, which is 2. And so once you identify those, then you just it kind of helps me to rewrite the formula so I don't miss anything. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. And then you're just kind of filling in what you know. I usually, like I told you before, I kind of write everything out where a, b, and c are missing just so I don't miss anything. And I'm always putting everything in parentheses just to be safe so you know what to do with negatives and all that. All right, let me see. So this was supposed to be a b, but I have a -7 for b. This is also b here. This guy's an a, which was 3. This is a c, which is 2. And downstairs is a, which is 3. All right, then once you replace, again, all the a's with 3, all the b's with -7, and all the c's with 2, then you're just simplifying this, and that'll be it. And then you get the solutions without having to do all the hard work from the previous section. So first we have a -7, that's a +7, plus or minus the square root of -7 squared. This is why I'm glad I put parentheses, because I know parentheses -7 squared is +49, but if I hadn't put parentheses, I might forget and put -49. And then we have minus, 4 times 3 times 2, that's 24. And that's all over, 2 times 3 is 6. All right, most of the work you're doing is whittling away at what's inside the square root. That's kind of the most complicated part of these guys. So the 7 and the 6 are just kind of sitting there waiting to see what happens. 49 minus 24 is 25, am I right? Yeah. All right, and I know that guy's square root. That guy is 5, so it'd be 7 plus or minus 5 over 6. And that's pretty much it. I mean, the only thing we could do now is split this into the two solutions and try to simplify. So in one case, the plus or minus will be positive. And the other case, the plus or minus will be a negative. Now we'll just simplify both of those and we'll be done. So here, 7 plus 5, that's 12 over 6, which is 2. On the right, we have 7 minus 5 over 6, that's 2 over 6, or 1/3. And there you have it. So just picture how hard, how much worse that would have been if we did completing the square. I mean, it took quite a few steps, but I feel like even though it's quite a few steps, it's a lot less brain power, a lot less to memorize, you know? Let's try this next one. This one looks fun. I'll try to do the same thing. So I know, and if you want, you could just kind of copy the same formula, but I'm just going to write, and I know the formula goes x equals -b over blah, blah, blah. But I guess this time our variable is w, so I better use w. It's -b plus or minus the square root of b squared minus 4ac all over 2a. But notice too, in this problem, your problem's supposed to look like ax squared plus bx plus c equals 0. So pretty much what you're supposed to have is all the terms on the left side. But in our example, we don't have that, so I'd actually better move everything over. That's one thing you got to be careful of in these problems. They're going to try to trick you and have everything, maybe everything mixed up, but it has to be in this form. This ax squared plus bx plus c. If you don't see everything in that form, every term on one side with a descending order of power, something's wrong. So I move the 3w over by subtracting it. It'll make it negative, and the same thing with the 5. There we go. So this is really what we want to deal with. That looks more like x squared plus bx plus c. So now let me identify. A is the coefficient of w squared, which is 1. B is the coefficient of w, which is -3. And c is the constant term, which is -5. So I'll use those when I substitute values in here. So it goes -b, which is here, -3. And then plus or minus the square root of b squared, which is -3 squared, minus 4 times a, which is 1, times c, which is -5, over 2 times a, which is 1. So if it helps, you might want to rewrite the whole formula again during each problem and then just filling in what you know. It's only okay for me because I've already memorized this formula a long time ago. All right, now we'll simplify this. You have a -3, that's +3, plus or minus the square root of -3 squared is 9. But be careful here because notice you have a -1 times 4, that's -4. But -4 times -5 is +20. So you got to be really careful because there you have a negative times a negative, which is a positive. I think people mess that up quite a bit. Be careful. So it's 3 plus or minus the square root of 9 plus 20, not 9 minus 20, which is 29 over 2. And then I'll split that into the two solutions. Oh, at this point I'm probably thinking, okay, can that square root be simplified? Well, 29 doesn't have a square root. And even if you try to break it down with the factor tree, it's prime, so there's no way to break it down. So really, all you can do is split it into the two solutions, but even then you can't really do much. I'll write it once with the positive, and then once with a negative, and that's about all you can do there. So it's actually kind of nice when the answers are ugly. It's like you have to do less work. When the answers are nice, then you have to do a lot more work. So I actually like it better when it's like that. All right, part C. I want to do something similar, but remember you want it to be in this form ax squared plus bx plus c equals 0. And I guess if I wanted to, I could say it's t squared. At squared plus bt plus c, because our variable looks like t. But I don't see that, so maybe I need to... You definitely don't see any parentheses in this form here, so you probably want to distribute that 2t. They like to do that a lot where they, I don't know, make it look way different, but once you kind of spread everything out, get all the terms on one side, it's going to be a lot better. But if I distribute the 2t, that'll be 2t squared plus 4t equals 1. And it's getting closer, it's just that I need everything on one side and a 0 on the other. So the last thing I need to do to get everything to be in the right form is move the 1 over. And now it looks right. 2t squared plus 4t minus 1. It's in descending order of powers, equals 0. Alright, now we're ready to identify what a, b, and c are. Here, a is the coefficient of the squared term, which is 2. B is the coefficient of t, which is 4. And c is the constant term, which was negative 1. So notice you could not have identified those in the beginning. It's hard to tell what... I mean, maybe a you might have guessed is 2, but you might have said b is 2 and c is 1, when it's actually b is 4 and c is negative 1. So really got to be a little bit careful. Alright, now maybe just to be safe, I might write the formula out again, because I haven't seen it in a while. And it should, usually you write x equals negative b plus or minus blah blah blah. But since our variable is t, I'm going to write t equals negative b plus or minus the square root of b squared minus 4ac over 2a. And then just replace everything. But yeah, it really helps me to write the whole thing over again with blank spots for a, b, and c. And that way I don't miss any negatives that way, and I'm not confused as to what to do with negatives and stuff like that. So okay, what was b? 4. That goes here and here. Oh wait, why'd I put a plus right there? Hello. This should be a minus 4. Hello, sorry guys. Minus 4, okay. And next to the 4 is supposed to be a, but a was 2, and then c was negative 1. The denominator should have a, which is 2. Alright, now it's just a matter of simplifying this guy. What'll I get there? Negative 4 plus or minus the square root of, let's see, 4 squared is 16. And then here you have negative 4 times 2, that's negative 8, but negative 8 times negative 1 is positive 8. So it'd be 16 plus 8. So I think that's where people make a lot of mistakes. They'll put a minus there, but really it's a negative times a negative, so it's a positive. So we got t equals negative 4 plus or minus, let's see, 16 and 8 is 24, I believe, over 4. And it's really tempting to reduce those 4s, but this is kind of like in that complex number section. You can't reduce those until you split this into 2 fractions, so be careful. I'm gonna make a little point for that. Can't reduce until we split into 2 fractions. And not only that, I notice I have a square root of 24, which can be simplified a little bit. And the square root of 24 is 2 square root of 6. If you use the methods from the previous chapter to simplify that guy. And now I'll split it into 2 fractions. One, where it's this over this, 4 over 4, plus or minus now this guy over this guy. Kind of like we did with the complex numbers in that couple sections back. And then you can reduce either one. That's negative 1 plus or minus. This 2 can cancel with this 4 a little bit to leave a 2 in the denominator. There it is. So that's kind of as good as that one gets. And just to be safe, like the homework always wants you to write 2 separate solutions. So one of them will have a plus, and then the other one will have the minus in the middle. There we go. There they are. All right. So even though it's kind of tedious and kind of seems silly, it's still a lot better than completing the square, right? It's like we had the worst experience of our lives, so everything seems a lot nicer now. All right, let's try part D. So looking at part D, I notice that everything's in the right form. It's already ax squared plus bx plus c equals 0. So I'm doing pretty good. I'm just ready to identify what's a, okay, 25, what's b, negative 20. Don't forget the sign too. B isn't just 20, it's the negative also. That could mess everything up. And then c, the constant term, is 4. And I guess I can't really see the formula, so I better write it again just to be safe. If you have it somewhere where you can just keep glancing at it, you don't really need to write it again if you don't want. You can just start kind of filling things in. Let me see, leaving blank spaces for all the A, B's, and C's. Alright, let me replace negative B. So be careful, because B itself is negative. So you're putting a negative in next to this negative. Negative 20 plus or minus the square root of B again is negative 20 squared minus 4 times A, which is 25, times C, which is 4, over 2 times A, which is 25 again. Got some big numbers here. So okay, let's see if we can simplify this. Negative 20 makes positive 20 plus or minus the square root of negative 20 squared is 400. And you got 4 times 25, that's 100. 100 times 4 is 400. So that's kind of a weird one. You got 400 minus 400 in there. Over 2 times 25, which is 50. And if you simplify what's in the square root, that's square root of 0, right? Because 400 minus 400. Alright, and the square root of 0 is 0. So this is like 20 plus or minus 0 over 50. Which looks weird, so if you want, that's kind of weird, but if you want to split it into the two solutions, that's not a bad idea. 20 plus 0 over 50, and 20 minus 0 over 50. Alright, well 20 plus 0 is 20, and 20 over 50 reduces to 2/5. On the right side, 20 minus 0, that's still 20. And 20 over 50 is 2/5. So it looks like we have two of the same solution, which really just means there's one solution. So that's kind of weird. Every problem we've seen so far, you have one solution. But this is the unique situation. This will only happen when the thing inside the square root is 0. Notice that's what happened. If you have anything inside there other than 0, you're going to get an actual, or two actual answers. So I don't know, in case you care, and this will actually, we'll talk about this in the next section. This happens when that part in the square root, you know, the b squared minus 4ac, when that ends up being 0. If that's anything but 0, if it's a positive number, a negative number, that won't happen. It's only when it's 0. Alright, so watch out for that. Don't feel like you did something wrong necessarily. Let's try part E. I notice this is almost in the right form. Looks kind of like ax squared plus bx plus c. Of course we have a y, but I don't see all the terms on one side. I'm going to have to move that 2 over so that everything's on one side. That way 15y squared plus 7y minus 2 equals 0. And it's in descending order of powers. You got y squared first, then y, then 2. So I'm ready to say a is the coefficient of y squared, that's 15. B is the coefficient of y, that's 7. And c is the constant term, not just 2, but negative 2. And I think since I have the formula right next to this problem, I'm ready to just kind of substitute things in. Y equals negative b plus or minus the square root of b squared minus 4ac. That's all over 2a. Alright, so I got b was 15. 15 here for b also. Minus 4 times... Oh wait, whoops. B was 7. Dang it, I'm mixing up b and a. Hello. Sorry about that. So b was 7. Sorry, 7. Minus 4 times a was 15. And then c was negative 2. All over 2 times a, which was 15. Alright. Sounds good. Let's simplify this guy now. You got negative 7 plus or minus, let's see, that's 49. And you got 4 times 15. Oh, sorry, negative 4 times 15, that's negative 60. Negative 60 times negative 2 is positive 120. And that's all over 2 times 15 is 30. So you got negative 7 plus or minus the square root of, that's 169, right? 120 and 49? Yeah. Over 30, going, okay, so far so good. Now what do we have? Let's see. Actually, 169 has a square root of 13. That worked out pretty well. All right, I think we're going to get some nice answers. You know you're going to get nice answers when the square root actually has a square root. It's not going to stay a square root. They call this actually, when the square root simplifies to a nice number, they call these, we'll see this in the next section, but they call these rational solutions. That pretty much just means no root left. If there is a root left, they call it irrational. So anyway, just good to know, not for this section, but for the next section. And now we want to split this into its two solutions. One of them is going to be the negative 7 plus 13 over 30. The other one's going to have the minus in the middle, negative 7 minus 13 over 30. So the left guy, negative 7 and 13 is 6 over 30, and the other guy's negative 20 over 30. Each of those reduces. The left one reduces to 3/15. Wait, no. Oh, 1/5. Hello. 1/5, because 6 goes into 30. Hello. 1/5. And this guy reduces to negative 2/3. Those are pretty nice answers. I like that. Okay, not bad. All right, last one. I think you probably already got the hang of this by now, but I thought just in case they throw a weird one at you like this one's kind of weird. It looks totally not like what we're used to. It's supposed to be ax squared plus bx plus c, like all the terms on one side, and they've got them all mixed up. They've got an x and a 9 on the right. Everything's kind of factored on the left. I need to undo that factoring. And then eventually I'm going to move these terms over to the left side. But maybe first I'll distribute. That'll make it an x squared minus 3x. And now I'm going to move everything from the right to the left. I've got minus this x to combine it with the 3x and add the 9 over there. Alright, now I think it's looking good. It's x squared minus 4x plus 9. There we go. And that equals 0. Alright, good. Now I think we're ready to plug it into the quadratic formula. I'm just going to write it again. If you want to look at it, you can, but it's negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Let me identify what a, b, and c are. A is the coefficient of x squared, so 1. B is the coefficient of x, which is not just 4, but negative 4. And then c is the constant term, so 9. In the formula, it starts out negative b, but b itself is negative 4, so it's negative negative 4 plus or minus the square root of b squared, negative 4 squared, minus 4 times a, which is 1, and c, which is 9, over 2 times a, which is 1. Here we go. All right. Simplifying this guy, you have a negative negative 4, which is positive 4, plus or minus the square root of 16. Then it's negative 4 times 1, that's negative 4. Negative 4 times 9 is negative 36, all over 2. Okay. Now let's simplify what's in the square root. 4 plus or minus would be negative 20, right, if you combine those guys? Now I realize this will be imaginary answers. Okay, but that's all right. We know how to deal with imaginary numbers now. So remember from a couple sections back, with imaginary numbers you can just get rid of the negative. So it was negative 20, I'm going to put positive 20, as long as you throw an I at the end. And remember, the I is not inside the square root, it's just outside. And now that I have the I kind of extracted, I can simplify. I know square root of 20, that reduces, or it simplifies to 2 square root of 5, if you use the methods from the previous chapter, and that's all over 2. And if I want to reduce this, I got to be careful because I can't just cancel those 2's. I have to write it as 2 separate fractions, maybe 4 over 2, and then that 2 root 5 over 2. Now remember, you're okay to split a fraction into pieces as long as there's only one thing in the denominator, like we have just a 2. Then you can go ahead and do that. And now either of these fractions reduces. This is a 2, and those 2's cancel just all together. It's just root 5i. So there we are. Now, if you want to write it as 2 solutions, you'll just write that once with the plus in the middle, and then you'll write it the second time with the minus in the middle. There they are. Alright, that's pretty much all there is to it to this section. I think you're probably enjoying this a lot more than you were the last section. And just to kind of bring everything back together, remember in the beginning of the last section we said the reason that we learn how to solve quadratic equations is because we're trying to figure out what the graphs of these parabolas look like, because these functions are parabolas, like this guy. And when we solve equations like this, we're finding the x-intercepts. But if you look at this last example, we got imaginary solutions. So how does that work as far as x-intercepts go? Like in the last one, I can figure out where it intersects the x-axis if it intersects at 1/5 and negative 2/3. Those are actual numbers. But what the heck about imaginary numbers? this would mean that the parabola has no x-intercepts. So if I think about what's the original problem here, I already forgot. How did this problem start? Well, I guess once we multiplied everything out, this is what we were dealing with right here, x squared minus 4x plus 9. So if I think of that as a function, x squared minus 4x plus 9, the graph is a parabola, but it's not going to have any x-intercepts. It'll probably look something like, like this. So it's entirely above the x-axis, which makes sense why it has no x-intercepts. So you're kind of looking for something that doesn't exist when you're doing this process. It's like, oh, let me do this process and solve this equation to find the x-intercepts. Well, if they don't exist, you're going to get some kind of solutions, but that's why it's imaginary. There's no such thing as these x-intercepts, because this thing doesn't hit the x-axis. Anyway, it's kind of interesting and how it relates and everything, why we have imaginary numbers and why they matter. But alright, thanks for listening, and we'll do more fun stuff in the next section. And of course, the next section, it gets funner and funner, as you can tell. But thanks for listening, and I'll see you in the next one. Bye.